Hey, hi everyone, welcome back to Windows Server 2016. Networking toolbox. Whether you are a network administrator, whether you are a server administrator, a network administrator, or a combination of the two, there are a number of tools that are useful for testing and monitoring network connections within the Windows Server world. Some of these tools are baked right into the operating system and can be used from command prompt or PowerShell. And some of the tools are more expensive graphical interfaces that require installation before running. Ping. Even the newest of IT pros is usually familiar with this one. Ping is a command that you can utilize from command prompt or PowerShell, and it is simply used to query an IP address to find out whether or not it responds. Ping is and always has been our go-to tool for testing network connectivity between two devices on a network. From my Win10 client on the LAN, I can open a prompt and ping IP address. Alternatively, because I am using DNS in my environment, which also resolves names to IP addresses, I can also ping server name, or as shown in the following example. You can see that my server replies to my ping, letting me know that the server is online and responding. Ping traffic is technically called ICMP traffic. This is important because ICMP is being blocked by default more and more often these days, with the existence of firewalls being turned on by default on so many of our systems and devices. Historically, ping was always a tool that we could count on to tell us fairly surely whether or not connectivity was flowing between two devices, but that is not always the case anymore. If you build a brand new Windows box and plug it into your network, that computer may be communicating with the internet and all of the servers on your network just fine. But if you try to ping that new computer from another machine on your network, the ping might fail. Why would that happen? Because Windows has some security measures built into it by default, including the blocking of ICPM traffic in the Windows firewall. So in that case, you would need to either turn off the firewall or provide it with an access rule that allowed ICMP traffic. Once such a rule was enabled, pings would start replying from this new computer. Keep in mind, whenever building new systems or servers in your network, that ping is not always the most trustworthy tool to depend on in today's networking world. Tracert. Tracert, which is pronounced as Traceroute, is a tool used to trace a network packet as it traverses your network. Really, what it's doing is watching all of the places that the packets bump into before hitting its destination. These bumps in the road that a network packet needs to get through are called hops. Traceroute shows you all the hops that your network traffic is taking as it moves along toward the destination server or whatever it is trying to connect. If I open up a PowerShell prompt from an internet connected machine and Tracert into a website such as Bing, we will get some interesting results. Tip: if you utilize Tracert but are not interested in seeing all of the DNS information provided in the output, use Tracert -D to focus only on the IP addresses. This information can be extremely useful while trying to diagnose a connection that is not working. If your traffic is moving through multiple hops, things like routers and firewalls before it gets to the destination. A tool like Tracert can be essential to figuring out where in the connection stream things are going wrong. In the preceding screenshot was a successful trace route to Bing. Now let's see what it looks like when things are broken. I will unplug my internet router and run the same Tracert to www.bing.com again. And now you can see that I am still able to communicate with my local router, but not beyond. Pathping. Traceroute is useful and seems to be the de facto standard for tracing packets around your network. But this next command is even more powerful in my opinion. Pathping essentially does exactly the same thing as Tracert, except that it provides one additional piece of crucial information. Most of the time, with either of these commands, you are only interested in figuring out where in the chain of hops something is broken. But often when I'm setting up servers for networking purposes, I'm working with servers and hardware that has many different network cards. When dealing with multiple NICs in a system, the local routing table is just as important as the external routers and switches, and I very commonly want to check out the path of a network packet in order to see which NIC it is flowing out of. This is where Pathping becomes more powerful than Tracert. The first piece of information that Tracert shows you is the first hop away from the local server that you are traversing. But with Pathping, it also shows you which local network interface your packets are flowing out of. Let me give you an example. I often set up remote access to servers with multiple NICs, and during this process, we create many routes on the local server so that it knows what traffic needs to be sent in which direction, such as what traffic needs to go out the internal NIC and what traffic needs to go out the external NIC. After completing all of our routing statements for the internal NIC, we test them out by pinging a server inside the network. That ping fails and we aren't sure why. I can try a Tracert command, but it's not going to provide me with anything helpful because it simply cannot see the first hop. It's just times out. However, if I try a Pathping instead, the first hop will still time out, but I can now see that my traffic is attempting to flow out my external NIC. We must have set up something incorrectly with our static route on this server. So then I know that I need to delete that route and recreate it in order to make this traffic flow through the internal NIC instead. Here is the same PowerShell prompt from the same computer that I used in my Tracert screenshot. You can see that a Pathping shows me the local IP address on my laptop where the traffic is attempting to leave the system, whereas the Tracert command did not show this information. Test connection, the commands we have discussed so far could be run from either command prompt or PowerShell, but now it's time to dive into a newer one that can only be run from the PowerShell prompt. This is a CMD LET called test connection, and it is sort of like ping on steroids. If we open up a PowerShell prompt in the lab and test connection web 1, we get very similar output results as we would with a regular ping, but the information is laid out in a way that I think is a little easier on the eyes. There is also an unexpected column of data called source. That is interesting. I'm logged into my DC1 server when I ran this command, and so yes, of course, my source computer from this command was DC1, but does this mean that I have the ability to manipulate the source computer from the test CMD LET? Yes, this is exactly what it means. As with everything in Windows Server 2016 management, the need to be logged into a local server is being decoupled specific to the test connection CMD LET. This means you have the ability to open a PowerShell prompt anywhere on your network and to test connections between two different endpoints, even if you are not logged into either of them. Let's test that out. I'm still logged into my DC1 server, but I am going to use a test connection CMD LET in order to test connection between a number of my servers in the network. You can see not only you can specify a different source computer than the one you are currently logged into, to take it a step further and specify multiple sources and destinations with this powerful CMD LET. So if I want to test connection from a couple of different source machines to a couple of different destinations, that is easily done with a command like the following: test connection source DC1, DC2, computer name web1, back1. You can see that I have ping statistics from both DC1 and DC2 to each of the servers web1 and back1 in my network. Test connection has the potential to be a very powerful monitoring tool. One more useful function to point out here: you can also clean up the output of the command pretty easily by using the -q switch. By adding -q to a test connection command, it sanitizes the output and only shows you a simple true or false for whether or not the connection was successful, instead of showing you each individual ICMP packet that was sent. Unfortunately, it does not seem that you can combine both the source switch and the quiet switch, but if you're using test connection from the original source computer that you are logged into, like most of us will be doing anyway, then minus quiet works great. Most of the time, all we really care about is yes or no as to whether or not these connections are working, and don't necessarily care to see all four attempts. By using -quiet, we get exactly that. If I were to use test connection in the standard way to try and contact all of the servers in my network, that would turn into a whole lot of output. But by using the -quiet switch, I get back to a simple true or false on whether or not each individual server could be contacted. Test connection, quiet computer name, web1, back1, DC2, CA1, Telnet. Telnet provides quite a bit of remote management capability. It is essentially the ability to make a connection between two computers in order to manipulate the remote machine through a virtual terminal connection. Surprisingly, we are not here to discuss any of the actual functionality that Telnet provides, because with regards to networking, I find it is quite useful as a simple connection testing tool without knowing anything about what functionality the Telnet command itself actually provides. When we discussed ping earlier, we talked about the downside to ICMP in that it is easily blocked, and it is becoming more standard in today's networks not to allow pings to be successful. This is unfortunate, since ping has always been the most common form of networking connection testing, but is the reality of today. If we cannot rely on ping to tell us with certainty whether or not we can contact our remote system, what do we use instead? Another case that I often see is where the server itself might be responding correctly, but a particular service running on that server has a problem and is not responding. A simple ping would show the server to be online, but it can't tell us anything about the service specifically. By using the Telnet client commands, we can easily query a server remotely. Even more importantly, we can specify to query an individual service on that server to make sure it is listening and it is designed to do so. Let me give you an example that I use all the time. I very often set up new web servers that are facing the internet. After installing a new web server, it makes sense that I want to test access to it from the internet to make sure it's responding right. But maybe I don't have the website itself online and functional yet, so I can't browse to it with Internet Explorer. Quite it is quite likely that we disabled pings on this server or at the firewall level, because blocking ICMP over the internet is very common to lower the security vulnerability footprint on the web. So my new server is running and we think we have the networking all squared away, but I cannot test pinging my new server because by design it fails to reply. What can I use to test Telnet? By issuing a simple Telnet command, I can tell my computer to query a specific port on my web server, on my new web server, and find out whether or not it connects to that port. Doing this establishes a socket connection to the port on that server, which is much more akin to real user traffic than what a ping would be. If a telnet command connects successfully, you know your traffic is making its way to the server, and the server service running on the port we queried seems to be responding properly. The ability to telnet is not installed by default in Windows Server 2016 or any Windows operating system. So we first need to head into Server Manager and add roles and features in order to install the feature called Telnet. Tip: it is important to note that you only need to install Telnet client on the machine from which you want to do command line testing. You do not have to do anything on the remote server which you are connecting to. Now that the Telnet client feature has been installed, we can utilize it from command prompt or PowerShell in order to work for us. By attempting to make socket connections from our computer to the remote service, all we need to do is tell it what server and port to query. Then Telnet will simply connect and timeout, and based on that result, we can know whether or not that particular service on the server is responding. Let's try it with our own web server. For example, I have turned off the website inside IIS, so we are now in a position where the server itself is online, but the website is dead. If I were to ping web1, I can still see it happily responding. You can see where server monitoring tools which rely on ICMP will be showing false positives here, indicating that the web server was online and running even though our website is inaccessible. Just below the successful ping in the following screenshot, you can see that I also tried querying port 80 on the web1 server. The command that I used for that is telnet web 180. That timed out. This shows us that the website, which is running on port 80, is not responding. If I go ahead and turn the website back on, then we can try Telnet Web 180 again. And this time I do not get a timeout message. This time my PowerShell prompt wipes itself clean and sits waiting on a flashing cursor at the top. While it doesn't tell me anything like, yay, I'm connected, this flashing cursor indicates that a successful socket connection has been made to port 80 on my web server, indicating the website is online and responding. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.